Hello everyone, this is a presentation on Villarica, Chile by Shannon Wiley. As you can see from the map, this volcano is located in the Andes Mountains of Chile in South America. This is a subduction zone associated with the Ring of Fire and most prominently contains andesitic magma with some basalt and rhyolite. The predominant type of magma from this particular volcano is basaltic andesite. Villarica has an elevation of 2,847 meters or 9,338 feet. It is a glacier-covered stratovolcano, meaning that it has very steep sides and can grow very tall. The major type of eruptions that happen at Villarica are Strombolian type eruptions. In the previous slide, I mentioned the Ring of Fire, so let's review what the Ring of Fire is. The Ring of Fire is a zone of subduction that goes in a ring around the Pacific Ocean. As you can see here, the Pacific Plate subducts underneath the Eurasia Plate and the Indo-Australian Plate. And over here we have the Cocos Plate subducting under Central America and the Nazca Plate subducting under South America, creating this ring of volcanoes around the Pacific Ocean. So let's think back to why subduction causes active zones of volcanic formation. Here we have a drawing of a typical subduction zone. We have our oceanic plate moving underneath our continental plate. We have a trench formation along the edge. We have the formation of magma here in the lithosphere right here. This formation of magma is caused by the introduction of volatiles from the oceanic crust. On top of this crust we have sediments that are hydrated and rich in minerals. When they get pressurized and mixed with the lithosphere down here, it lowers the melting temperature and we have magma formation. The magma then migrates towards the surface of the earth because it is more buoyant than the surrounding rock, and because of its composition, it being that of continental crust mostly with a little bit of oceanic crust mixed in, the magma tends to be highly viscous and it traps the volatiles, the gases within it. This, as we have reviewed in class before, causes explosive eruptions and the formation of large volcanoes. This happens all around the Ring of Fire, as was shown in the previous slide. So if you remember from our class on eruption types, a Strombolian type eruption is the smallest of the explosive eruptions. It is more energetic than Hawaiian eruptions because the magma is more viscous. However, it's not as energetic as a Vulcanian or other type of explosive eruptions. They are characterized by brief, frequent, and repetitive blasts of magma and other pyroclastic material. The lower viscosity of the magma in the chamber prevents massive explosions. However, the material is starting to resemble andesite and pressure does build up, causing the brief explosions. Due to the lower energy of these eruptions, the debris tends to settle near and around the vent, forming a cone. These types of eruptions are named after the Stromboli volcano, the island of Stromboli in Italy. Here we can see the Stromboli type eruption. We can see that it does have an ash column, however it is not as big as a Vulcanian or a Plinian, and the magma we can see once it's out and it's lava, it is not rolling down the sides of the volcano like in a Pelian type eruption, and we can see it's definitely more energetic than a Hawaiian type eruption, which has no ash cloud or explosive elements to it. And we can see all of this material is falling close to the top of the volcano, whereas the others have a more a wider range of material as to where it's going. However, in a Strombolian type volcano, especially Villarica, because of its glaciers and snow top on it, it can form large lahars, which is a mixture of pyroclastic material and water, especially during melt season or during the rainy season. There is some evidence of pyroclastic flows on Villarica, but they're in the distant past, and the eruptions don't seem to be quite so energetic these days. So here we have a picture of one of the most recent eruptions on Villarica. This is a common type of eruption. It occurs pretty frequently there. They have 4 levels of warning. Yellow, they have been living under a yellow since about 2015. So this volcano, there's evidence of it erupting quite largely in the BCE time period. However, it's been steadily erupting every few years in these Strombolian type eruptions since about the 1300s. It is one of the most active volcanoes in the region. It is one of Chile's most active volcanoes. It tends to put on a good show and evacuate people every now and then, but they live under the constant threat of this volcano erupting. Speaking of this volcano erupting all of the time, it has had a sort of ongoing event since late 2014, early 2015. They're not sure of the exact start of it because sometimes volcanoes like to erupt in the middle of the night. But since about then, it has gone through periods of increased activity and decreased activity, but never a pause in activity. So it's been sort of one single eruption event with a lot of smaller eruptions within it. So this is marked by degassing of the gases in the chamber, increased seismic activity, ash bursts, some pyroclastic flows, and of course our Strombolian eruptions. Activity seems to increase and then decrease, so it goes through like it'll go up and then it'll go down, but then it'll always come back up again, at least for the last handful of years. On most recently, on October 12th, there was a discovery of a tephra deposit, and if you remember, that's just the fragmented material that gets exploded out of the volcano. There was one discovered that was 20 meters wide and 3 kilometers long, coming down out of the volcano on the northeast flank. And then on November 4th, there was a degassing event with a 300-meter ash cloud that came out of the volcano. So as you can see, it's still pretty steadily erupting, even into the end of 2020. So in the last slide, I mentioned the tephra deposit that was 3 kilometers long to lead into the impacts on humans in this area. There is just over 500,000 people within 100 kilometers or 62 miles of Villarica, the volcano. It's a town named Villarica. And within 5 kilometers, there are 500 people. Back in 2015, part of this eruption caused the evacuation of 3,000 people over from nearby villages. They are still maintaining a level yellow alert for the municipalities surrounding it. But as you can see, there are just over 500,000 people that live within close range of this volcano. So a massive eruption could cause the evacuation of 30,000 people or more, which is just under the size of Windsor currently. And that's my presentation on Villarica. I hope you guys enjoyed it.